From our years in high school, you should remember the physics class lesson, where we studied everything about the pendulum and how its period of oscillation is calculated, or how this period is dependent upon its length. In this video, an apparatus is constructed resembling a pendulum. This construction and its details will help to experiment on how to calculate its period of oscillation. The construction includes a light sensor which measures the percentage of the red LED light returning after hitting a surface. Looking at the sensor in detail, we can see there is a white reference surface, the tip of a white angular beam 5x3, fixed and suspended from above. Due to its white color and the close proximity to the sensor, the light sensor usually returns a value greater than 50%. This value is used to determine the timing between two consecutive oscillations and thus helps to calculate the period, T, of the pendulum. To do the experiment for calculating the period, T, of the pendulum oscillations, the following should be done. 1. The application, LEGO Mindstorms Education EV3 Teacher Edition, will be used to log the data of the experiment. 2. The dataset produced by the app will be saved as a comma-separated value text file, a file that has a CSV name extension. 3. This file in turn will be opened by a spreadsheet app and will be processed to determine the period. Please watch carefully and see how. First thing is powering up the hub and wait for a few moments for it to come to life. From the main menu of the app at the top we access the File menu. Then we choose New Project and finally we choose to do an experiment. We should connect the activated EV3 Hub via Bluetooth, by ticking the empty square, next to its name in the list. If the hub is not there, we check if Bluetooth is actually active on the hub. We look towards the left side of the window app and find the experiment units set up. There we change the duration from 10 seconds to 6 and the rate to 100 samples per second. Now we are ready to run the experiment. We look towards the right end of the window app and press the play button, while we push the hub, pendulum to make it oscillate. After a characteristic sound, the experiment starts and peaks are drawn at the screen. These peaks are the values of the sensor during the moments the sensor passes directly in front of the white surface reference point for the oscillating hub, pendulum. But we actually need every other peak, as shown on screen. Then we save the dataset values shown on the graph, by going at the top menu and choosing Tools, and after that, choose Exporting Datasets. Before saving we make sure the exported file type has a file extension *.csv. We then open the spreadsheet app. We load the dataset file and from the two pairs of numbers, time and sensor value, listed on every line of the file. We keep only the lines where the sensor values are at their maximum, ignoring the minus sign, before dropping to 0. But remember, you need to keep every other maximum and delete all lines in between. When only 6 to 10 lines are left on the table, subtract the values as shown. From the differences, these values should be nearly the same. By computing the mean value of all items, the value computed is the period, t, of the pendulum.